This time, let's try creating some bricks with Voronoi. Bricks are a very useful asset when creating destruction, and they're a little bit trickier to create than one would expect. Let's create a very simple wall using the box tool. So control click on the box icon, dive into the geometry node, and let's change the parameters of the box to 8 meters in X, 2 meters in Y, and 0.4 in Z. Let's also move the wall upward 1 meter. Now I will press spacebar and F to frame the view. And let's create a Voronoi just after the box. This time, instead of inputting a scatter or a volume scatter node, I will create a line pointing upward, and I will make sure that the line has the same height of the box, and that can be easily done by selecting the box node, right-clicking on the Y size, copying its parameter, going back to the line, and copying back the parameter as a reference in the length channel. So right-click on the channel and click Paste Relative References. So now we have a 2 meter line, and I'm going to increase the points to, let's say, 10. I will connect the line to the wall. Now notice how the wall was divided horizontally in exactly 10 segments. I will just add a transform node. So I will click Tab, type transform, and press enter, just to offset the points a little bit upward to have rows of the same height. Now the tricky part is how to divide all these blocks so they are offset on every other row. And for that, I'm going to create a for each loop. So type tab and start typing for each, and we're going to select for each connected piece. Let's now connect the Voronoi node to the connectivity node, and the for each will run over each of these connected pieces that were generated by the connectivity node. So if you take a look at the connectivity node, it's creating a new class attribute for each of the connected components or each of the connected primitives of this geometry. So let's make some space here. We're going to create a few more nodes inside the for each loop. And first of all, let's create a points from volume, just as we did with the last exercise with patterns. And we know this will generate a very even distribution of points. Now let's create a Voronoi fracture. Let's connect that to the for each begin, and then connect it to the for each end. And I will also connect the points into the second input of the Voronoi fracture. So as we did earlier, we have now a very even distribution of cubes, one on top of another. And what we actually want is each row to be offset from the previous one. So first of all, let's increase the point separation, let's say to 0.6. And then let's just click on the for each end to see how it looks. And I notice here there's a few of the rows that are not being cut. And this is because we don't have enough density of points going through these blocks. So let me connect, for example, the points from volumes here to the connectivity node, so we can see the amount of points that are being generated. So we would need to decrease the point size or the point separation, so we have at least one row of points going through the geometry or through each row of bricks. So let's decrease to 0.25, the point separation. Let's connect it back to the for each begin. And let's see what we get. So this is much better. Now we have all of the rows being cut in squares. And I will scale on X the points so we get rectangles rather than boxes. So add a transform node just below the points from volume. And let's increase the X scale to say 3. And this is looking much better. Now to create the offset between the rows, we will need to use a point wrangler. So press tab and type PW, enter to create a point wrangler. Connect it after the transform node. And I will give some space down here. I will change the color of the point wrangler to purple or something I like. Press C to open the color swatch and press C again to close it. And now we will need a method for the point wrangler to know which of these rows it is operating on. And to do that, I will click on the for each begin. And you will notice here we have a button called Create Meta Import Node. So click on this button. This will add a new node to the right called For Each Begin Metadata. And let me call this Meta, just for short. And if you select the node and go to the geometry spreadsheet, you will notice how this node has a few attributes, one of which is the iteration. So this way we know in which iteration of the for each loop we're actually in. So we're going to use this information to drive the point wrangler. So go back to the scene view. Let's click on our point wrangler and let's connect this meta node to the second input to the point wrangler. So I'm going to retrieve this iteration attribute to use in an if statement within the point wrangler. So type the following: if, open parentheses, detail, open parentheses, and then type 1, comma, open quotes, and type iteration, close quotes, type comma, then 0, close parentheses, and then we're going to type modulo, which is shift 5, then number 2, equals 0, and close parentheses. So what we're saying in this line of code is retrieve the detail attribute called iteration from the port number 1. In this case, this meta is connected to port number 1 and it has a detail attribute called iteration. So run this value, divide it by 2, and if the remainder of this division is equals to 0, run the following code. If not, just ignore it. And how do we know what's going to result from this division? So in iteration number 1, 1 divided by 2 is 0.5. So the if statement will return false. The second time that the iteration is run, so iteration number 2, will be divided by 2. And since the remainder of 2 divided by 2 is 0, it will result in true. And so on. So what will happen is every even number will be offset or will be run through the if statement. So let's type the following. Open the curly brackets, then type a few spaces, close curly brackets, and between the curly brackets, let's type v at p dot x, so the position in x, minus equals So subtract the following from the X position. And let's create a channel. So type CH, open parentheses, open quotes, and we'll call this channel offset, close parentheses. Actually, first of all, close quotes, close parentheses, and then type semicolon and Control Enter to evaluate. So now click here on the button to the right to create the actual offset channel. And now you will notice as we increase this value, only the even number of rows will be offset to the left or to the right. The even columns, or actually the odd rows, will stay in place. So they will ignore this line of code. So our brick wall is looking good. The only thing I want to add is probably a bevel to the edges. And one more thing, if you notice here on the info for each node, you will notice how now we have the class and the name attribute. The class, remember, was created by the connectivity node, and the name was created by the Voronoi. So we could delete these two attributes. For now, we won't need them. So let's lay down an attribute, delete. And under the primitive attributes, we can delete both. And finally, we will add a poly bevel. So if increase the distance of the bevel, we will avoid these very sharp edges. And here we probably want to change, instead of a chamfer corner, we want a round corner. And maybe also increase the divisions, just to have a little more detail here. And finally, if you want to check out the individual pieces, we can add an explode view. And these are the individual bricks.